Now, this part of the lesson deals with adding fractions with different denominators. Now, from our last video, you've seen several examples of adding fractions with like denominators. This time we're going to deal with adding fractions with different denominators, or what we've called in mathematical terms, unlike denominators. All right. The rule of thumb, there's a formula that most school teachers have taught their students, and it's in the form of determining the common multiple factor when you have two unlike or different denominators. And this is in the term of, remember the formula, A over B plus C over D. All right. B and D represents the unlike or different denominators. And when that happens, when you have a fraction that has, when you have the sum of two fractions, they will have unlike denominators. You need to determine the common denominator that both fractions share, and then you'll create the new denominator, and then you will determine the new numerators. Part of the formula is in this form, and I'll demonstrate it when you have the opportunity to see one of the examples described in this video. A times D plus C times B, put that both in parentheses, over B times D. Notice the B times D represents the product or some type of common product between the two denominators. All right, let's translate this using a sample problem, using an example. I'm going to write this. What is 1/6 plus 2/9? All right. First thing you need to do is find the common multiple between the two denominators of these two fractions. Okay. Step 1, find the common multiple. All right. So when you find the common multiple, what you're going to do, you're going to determine what two factors that you can create your new denominator. All right. So what I'm going to do, I'm just going to show you. All right. I'm going to use this as scratch sheet of paper, as scratch work. All right. Down here, I'm going to draw a line, and that's going to represent the difference between these two fractions using this formula. All right. Now I'm going to do this. All right. I'm going to translate this to another part of the paper. 1/6 plus 2/9. All right. I'm going to put parentheses around this. All right, because this is my scratch work. All right, because I'm going to try to obtain the new denominator and place it here, and then capture these values in the numerator, because we're going to use this formula. All right, so what I'm going to do is find out what common denominator between this. The common denominator between these two fractions is, you can do the product, you can reduce it, but if you can find two common factors that can have a common multiple that share between these two fractions, you're good. So it seems like 6 and 9, a common multiple that I can think of that will have a factor of 6 and have a factor of 9 is 18. All right, so I'm going to take this, multiply 18 on both sides of the fraction. All right, this will be your combination that will fit the common multiple in this formula, because what I'm going to do is 18 represents a whole number. 18 on this side represents a whole number. Or you can say 18 over 1. It's the same thing. So I'm going to use cancellation, all right, to cross out and cancel the common denominator. So my common denominator for the new fraction is 18, all right? Okay, then I'm going to cross multiply. I'm going to 6 into 18. You can see here that it goes 3 times. All right, cross this out, which I'll have cancellation. And then I have 3 left over. It'll be 3 times 1. And this is where your A times D comes in. All right, when you find the common multiple, you multiply the common multiple on both sides of the fraction so that you can capture the remaining factors that will be multiplied in the numerator. And this is where this form comes in. So this crosses out or cancel. The 3 is left over from, when you have your 18 divided into 6. How many times will 6 go into 18 3 times? You have 3. 3 times 1 is 3, and that's where this part of the formula comes in. So you have 3 plus, all right, and I'll do it on this side. How many times will 9 go into 18? Twice. Cross this out, all right, and have 2 left over. And then the remaining 2 will be multiplied in this numerator, all right. 2 times 2 is 4, all right. So I have my 3 plus 4 over 18, and add that, you have 7 over 18, all right. Now, if you use the common multiple as 54, that's fine. It will still work out the same. You will have to reduce it to the lowest term. But if you find a common multiple that both factors in the denominator share, they both share, you can save the trouble of you trying to reduce to the lowest term after you've secure the common denominator that both factors in the denominator share. So when you have different denominators, you can create a common denominator, multiply the common denominator on both sides, and then capture the factors from the common denominator that will be multiplied in the numerator, and then, you can put it together and perform the summation or the addition of the fraction. Let's try another one, and we'll do this. Okay. Let's do this. Instead of writing what is, let's do 7/9. All right. Zooming in like just a little bit. 7/9 plus 1/5. We'll do something simple. All right. We'll do it so that we can determine which common factors that both fractions share in terms of the denominator. So we have unlike or different denominators. Again, let's just put this all together so that you can understand the process. We're going to do the same thing. So I'm going to draw a line. This will be my fractions that share both denominators. Okay. Now I'm going to determine the CM, or the common multiple, or the common denominator, what people call. You could say CM or CD, whichever you like. So the factors that 9 and 5 share, the closest one I believe is 45. All right. So I'm going to write 45 here. This is my new denominator. Okay. Then I'm going to take that 45 and multiply it on both sides of the original term or expression. All right. I'm going to use this to cancel out and get rid of the old denominators, and then capture the values in the numerator and put it here that makes up the new common denominator. And I'll proceed right now. 45 and 9 will go 5 times. Okay. 5 times 7 is 35. You can see that from the earlier formula that you multiply A times D, and that's where that comes from. All right, this is where it comes from. All right, so that cancels. 5 times 7 is 35. I'm going to do it on this side too. 45 and 5 will go 9 times. I have my 9 left over. Multiply 9 times 1, which is 9. Okay. Now I have a common denominator, and then I've captured the values or factors from the numerator based upon what was canceled from the denominators. All right. So I don't have to worry about this no more because this is my new fraction. Both fractions share the common denominator, and that's what you want. Then you add these two numerators because they have the same common denominator. So that will be 44 over 45. And 45 fifths is a proper fraction. And you know that proper fraction means that the denominator is the largest. So there's no reason to, and there is no other way to reduce this term. All right. Okay. All right. Please practice more expressions later in your Play-Doh or on your own when you're looking at your textbooks. Examples from your Barron Praxis 1 PPS T booklet. All right. You have a good day.